Oh, I see a raised hand. How polite.
Hi. Yes, I had a question because I saw in the second week we had like a homework assignment. I was wondering if the assignment is like the same thing as the quiz.
Yeah, it's meant to prepare you for the quiz questions.
Okay, and so we can do it when. So today is the date, limit date to the assignment. Yeah.
Yes, and I want to talk about it because I grabbed a screenshot of our Moodle page for this week. And so let's see here. Okay, I gotta keep this open. Okay. So I wish I could say it was on purpose. It was not. I set up the quiz and then I forgot to show it to students. That doesn't help you guys at all. So what I did was I've set it so that it's available from 1:30 today until 1:30 tomorrow. So you'll have 24 hours because you were meant to have all day today, but because we're still wrapping up material, it does work out. So I decided to just give you kind of 24 hours instead. Right. It is a 20-minute timed quiz. So once you start, you'll only have 20 minutes. Okay. And I think it's 4 questions. Quiz 1, I think, is 4 questions. Pretty sure. Okay. You'll only have 1 attempt. You're not going to have the check answers option. So just it is what it is, and it's just meant as a little check-in. Okay, so nothing crazy, and if this quiz doesn't go well, then that's totally fine. It's not something to freak out about. I go through and I check your answers because sometimes it's marked incorrect because you forgot a dollar sign or something, right? And so it could be as simple as that. So then I'll adjust your marks. So I do go through and I look at your answers. And if the value is correct or kind of close, then I give you those marks. Okay, so I do go through it afterwards and just adjust your marks. I also posted assignment 2, which will be due January 30th, so next Monday at midnight. Okay, it does include quite a few practice problems from 1.6, which is on the quiz. 1.6 is just about percentages and proportions and all that fun stuff. So basically, how do you calculate taxes? And so I don't know, it's just kind of fun, right? You get your bill and you need to figure out how much to tip, for example. Those are the examples that we'll go through. And so that's what 1.6 is about. Yeah. Another thing I did, because it seems like the textbook is kind of unavailable to a lot of people, and so I'm not supposed to do it, but I did it anyways. I took my textbook and I scanned it. So it's very messy looking. So it's not a beautiful PDF or anything. I scanned it, and so I posted, it's in multiple parts. And so I posted part 1, which is chapter 1, which is kind of like the basic math. And then I also posted the appendices because in case you want the solutions to some of those practice problems in there. Okay. I'm not going to take a screenshot, but I also posted on our YouTube page. Yeah, no problem. I know I don't know why the textbook is not available, but I'll see what I can do. Now you know I have scanned versions of it, so you'll just have to keep it and don't share it. so I don't get in trouble. That's important. Okay, so our YouTube page is not loading. That's okay. I just added videos from previous terms where I approach that solving the systems of equations from, I think I solved for X instead of Y, for example. And so you're welcome. And so there's lots of resources, right? And that's where I want to pick up today is another example with systems of equations. Now, if you watched those videos from a previous term, this will be, I'm going to say it all over again, but that might be nice for some review. Okay. So just some quick review. We did expanding and factoring, I think is where we started. Can't remember. Expanding, factoring. And then we introduced solving systems of equations. Solving systems of equations. Specifically, we were looking at two equations and two unknowns, right? As many unknowns as you have, in our case, we have X and Y, or you can call them A and B if you want. As many variables as you have to solve for, that's how many equations you'll need. Okay. Oh yeah, there's no midterm, but there are 3 tests throughout the course. And I'm still kind of figuring out when that is because we got off to a rocky start. So I have a test date, but it's not looking good. So I'm gonna have to sit down and really look at it. And off the top of my head, I think it might be after chapter 3. So we're still in chapter 1, so we've got a little bit of time. So 2 equations with 2 unknowns is what we're going to be solving for. Oops, unknowns, right? X and Y are typically how we denote our unknowns. All right. We'll see a couple of other versions. Yeah. And so what we said was we would use, or I always prefer by substitution, so solving by substitution. Okay. But now that you have the a little bit of the textbook, you can also solve it or solve by elimination, but we're not covering this. It is in the textbook, but I'm not going to do it by elimination. Okay, so this says covering that. It's not very clear. So that's kind of the end of our review, but I do want to start by solving another system of equations. Okay. Oh, and before I forget, we're going to end at, what is it? It gets confusing because I'm in Edmonton right now and they're an hour ahead. And so I have to, when I look at the clock, it gets confusing, but we're going to end at 1:30 instead of 1:50. Because that's your time to do the quiz. You don't have to do the quiz then, but I just want to give you time if you need it, right? Who knows how busy your schedules are? Not I. Okay, I'll start it on a fresh page here. So we're gonna do example 28, and we're gonna solve 2x plus y is equal to 4. And x plus 1/2 y is equal to 2. Okay. So Maybe it's been a while. Maybe you've been practicing all weekend. I don't know, right? But for me, I like to label my equations so that I can talk about it and make notes to myself, but also notes to you, obviously, because that's why I write my notes. Okay? And when I look at this, let's see here. I have 2x and a y on its own. That y is very tempting, and I will be solving for y in equation 1, right? I could also be solving for x in equation 2, but then I have to deal with this fraction all along, right? Which is kind of annoying. And so, so for me, don't worry, there'll be fractions anyways. There's no getting around it. But for me, I'm going to solve for y in equation 1. Okay, but however you want to do it is totally fine, and you can play around with it and you'll end up at the same solution as I will. Okay, so I will solve. Hey, no. The dog is chewing on everything. I will solve for y in equation 1. So I've got 2x plus y is equal to 4. Solving for y, what do I have to do? I'm going to get y on its own. For me, I like to just subtract 2x from both sides. And so that looks like y equals 4 minus 2x. Okay. So now I have y on its own. That's great. Now you want to be really, really careful that you don't put that back into the first equation, right? Because that's where you kind of mind the y equals 4 minus 2x from, right? But you want to put it into the other equation, right? And so here, now substitute y equals 4 minus 2x into equation 2. So equation 2 is x plus 1/2 y equals 2. Now I'm going to just write that out, and then I'm going to substitute it in. So I have x plus 1/2 times 4 minus 2x is equal to 2. And if you prefer, maybe I should write it like, oh, that looks weird. Like that, 1/2, right? Because what we're going to be doing when I multiply by a fraction, I'm really just dividing. She's a bad dog. Let me just go. Hey. Okay, never mind. I guess she's fine for a little bit. All right, so what do I have to do, right? I have to expand this 1/2 into 4 minus 2x, right? And so now I'm going to have x plus 4 divided by 2 minus 2 divided by 2 times x equals 2. All right. You want to be careful that you expand that fraction onto both of the terms. Right? But now we've got some easy math heading our way, right? We've got x plus 4 divided by 2 is 2 minus 2 divided by 2 is 1, right? So just minus x is equal to 2. What's the problem here? There's a problem, right? If you're kind of looking ahead, x minus x, okay, nice. I'm collecting like terms, and all of a sudden, I just have 2 equals 2, right? And so here, I get just these go away, and I get 2 equals 2, right? So this can happen if we're solving systems of equations. This can happen because 2 equals 2 is true, right? So, but it's always true. It doesn't matter what x is, and therefore it doesn't matter what y is. 2 equals 2 will always be true. Okay? And so here, right? That's a possible result, is you get some number equal to that number, right? That's a true statement, okay, but it doesn't give us any solutions. And so as 2 equals 2 is a true statement, and the thing is that it doesn't specify what x is, right? It's true for all values of x. Okay, so as 2 equals 2 is a true statement that doesn't specify what x is. Okay. We have an infinite number of solutions. We have an infinite number of solutions. One thing that you can do to check your answers is if you have the Desmos graphing app, which is free, right? So we can check our answers. We can check our answers using the free Desmos graphing app. So what would this look like if I graph this? So the Desmos graphing app is the one with the lines. So what I'm going to do here is I'm going to enter the 2 equations that I have. And as I enter the equations, it's going to graph them. And so my first equation was 2x plus y. Notice that it has the x's and the y's, and so that's convenient, is equal to 4. Okay. And so that's how we would graph that line. And we're going to spend some time either today or next day, depending on kind of our speed here, talking about how we properly graph lines. But it's always nice to be able to check your work. And so I recommend this app. And like I said, it's just free and it's easy to use, and that's nice. Okay, so then my second equation was x plus 1/2, and then I need to step it up, y equals 2. So notice how this line is mapped on top of the red line. They're exactly the same, right? And so how could I have seen that just mathematically, right? It looks like if I multiply equation 2 by 2, I get to equation 1, right? And so, or vice versa, if you divide equation 1 by 2, you get to equation 2, right? And so, so that's why they're the same line here. Okay, so let me just, oh, that's loud. Screenshot that. Okay. So here, right, we see these lines are the same. Yeah. So that's what it means when you have infinite solutions, right? When you have an equation, so you find a solution like 2 equals 2, what that means is that the lines are overlapping, right? And that equates to infinite solutions. Okay. So therefore, when 2 lines are overlapping, we have infinite solutions. Right? Because lines extend to positive infinity, negative infinity, guess I did those the other way around, but right. And so lines are infinite. And so that's why we have infinite solutions. Okay. In a similar scenario, what can happen is, what if you arrive at something like 4 equals 2, right? That's a false statement. Okay, so here we have a true statement. If we have a false statement at the end, which can happen, what that means is that there are no solutions. Okay. And so in a similar scenario, and I wish I had pulled an example. You'll just have to trust me. I don't have an example that I know will give infinite or 0 solutions. But in a similar scenario, if you get, can I say to the end? That's not a mathematical term, but to the end, right? And find a false statement. No period yet, right? But I just want to highlight the difference here. Here I have, so a true statement means that there are an infinite number of solutions, and a false statement means that there are no solutions. A false statement like 2 equals 0, that's false, right? That's not true. Okay. There are no solutions. To the system of equations. Graphically, what would that look like? They would never intersect, right? And so in terms of a graph, they would be parallel like this, right? And so, and they have to be exactly parallel. Otherwise, at some point, they will intersect, right? And so graphically, if there are no solutions, the solutions are really intersections, right? So no solutions, that means no intersections. Or no intersection, I guess, one, right? The 2 lines are parallel or exactly parallel, because even if they look like like sort of parallel, if there's a slight tilt, right, so a slightly different slope on one of them, eventually they will meet up, right? So it just happens way out in some at some large values of x, right? But if there are no solutions, which means there are no intersections, the 2 lines are exactly parallel. Good. So like I said here, in that scan that I gave you, okay, it is asking for, so using substitution and then using elimination. I would just use substitution across the board, it doesn't matter. And then the solutions, probably to the odd ones, or I can't remember which ones, are in the appendices that I posted, right? So there are lots of, and then using any method. I've only shown you substitution. So that's what I'm kind of expecting to see. Okay. I think we're ready for section 1.6, finally. chapter 1's kind of all over the place because we're just trying to get up to speed on math in general, right? But we'll come back to systems of equations in chapter 2. So we haven't seen the last of them yet. They're kind of important. Okay, where's my page break here? I'll start it on a fresh page. Why not? So 1.6 is on ratios, proportions, and percentages. I'm not going to focus so much on ratios because we're not going to really use them later on, but we are going to use proportions and percentages. Okay, so that's where I'm going to focus. I'll bring up a ratio just to give you an example, but we're going to focus on proportions and percentages. Now, proportions and percentages, they're the same, right? It's just that a proportion times 100 is a percentage, right? And so these two are the same, essentially. So a proportion times 100 equals a percentage. So that's important, right? A proportion is a value between 0 and 1. Yeah. And so here a proportion is a value between 0 and 1. Okay, so it's going to be a decimal, right? And then when I multiply by 100, I get a percentage. Right? For us, it is possible to have answers like 110%, but in general, a proportion is a value between 0 and 1. Okay. So even though a lot of our kind of daily communication, especially in business, is in percentages, right? We like to report percentage increases. We like to report, tips as percentages, all those types of things, right? So many things are reported as percentages, but in order for us to do math on percentages, we should be converting them to proportions first, right? By dividing by 100. And then that way, when we do our math, it's going to be a little bit cleaner. And so we do math on proportions, but then when we talk about proportions, we convert them to percentages. Okay. So let's see here. So to use percentages, or maybe I'll start with that little preamble here. We often use percentages when reporting information, right? So it just kind of in our daily lives when reporting information. Yeah. But in order to do math with percentages, we first need to convert them to proportions. But in order to do math with percentages, we should first convert them to proportions. I'm not saying it's impossible to work with just percentages, but it makes it a lot cleaner if we convert to proportions. Okay, but in order to do math with percentages, we should first convert them or convert to proportions by dividing by 100. So a proportion, I wrote a quick note, but I think it's worthwhile talking about what a proportion is. In general, right, as long as you remember that it's a value between 0 and 1, then you're fine. But a proportion is a fraction. often written in decimal form and takes values between 0 and 1. Often written in decimal form. And takes on values between 0 and 1. Okay. It's not an example, but from page 27, and I'll grab a screenshot of it here. This is all we're going to talk about in terms of proportions. And it's kind of a cute one, so. And maybe. Because like I said, right, we're supposed to talk about ratio. Oh, sorry, it's kind of lagging here. I see. We're supposed to talk about ratios. This is all I'm going to say in terms of ratios. And then we're going to focus on proportions and percentages. All right. And so this is the only thing that I'm going to say about ratios, which means it's not terribly important for us. So here, just about ratios. Suppose that there are two goods, so two things required to make a good sandwich, peanut butter and bread. Maybe some jam, 3 things. We know that it takes four spoonfuls of peanut butter to cover 3 slices of bread. So the ratio, right? The ratio of peanut butter to bread is 4 to 3. So we write 4:3, right? Where 4 represents the peanut butter and 3 represents the bread. Okay. We can also rewrite this as a fraction. Right? For example, suppose that we have 75 slices of bread. How many spoonfuls of peanut butter do we need to make sandwiches out of those 75 slices of bread? Right. And so we're going to let X and Y represent quantities of peanut butter and bread respectively. Okay. And then, so here, so what we're going to have is we have X equals peanut butter and Y equals bread. Okay. And we said that, okay, the ratio is 4 to 3, right? X to Y. Okay. So X to Y, this is how we report a ratio sometimes, but we can also write it as a fraction, right? And it's just going to be X divided by Y. Ratio can be written as a fraction. X over Y. Okay. So what we have, if we want to solve this, is we were told that, okay, 4 scoops of peanut butter to 3 slices of bread in general equals X over Y. So now what I'm going to do is I'm going to specify that, okay, I have 75 slices of bread. Now the bread is the Y. So what I'm going to do is I'm going to replace this Y with 75. All right. So then I'll put on a fresh page here. 4 over 3 is X over 75, right? Solving specifically for 75 slices of bread. What I find a lot of the time with ratios is your brains probably solved this problem already, right? how you did it may not be the way I'm writing it down on paper, right? And so just kind of sit back and think about how your brain solved the problem. And if you had to write it out, it would probably become something very similar to what I'm writing down, right? Because but a lot of these problems we can already solve. We just don't maybe have the math language to write it down on paper, right? And so how we're solving it here is through a ratio. Okay. And so what do I have? Okay, I need to solve for X. I want to know how many spoonfuls of peanut butter do I need? And so there are a couple of ways that I could solve this. For me, I like to just solve for X on its own by doing what? By multiplying both sides by 75, right? Moving that 75 over to this side. Another thing you could do is you could cross multiply, which would involve multiplying 75 over to the left-hand side, but also multiplying 3 over to the right-hand side. But then you'd have to solve for X again by dividing by 3. So dividing it back over, and I just like to cut that step out. So here, right, what I want to do is I want to bring this guy over here, right, solve for X. So I have 4 over 3 times 75 is equal to X. Multiplication and division can be done in any order, right? So I have 4 times 75 divided by 3, or if you prefer, 4 divided by 3 times 75, you'll end up at the same answer, right? And so what we're going to get is, I'll use my, clear all. Okay. I'm going to do 4 divided by 3 times 75. Which puts me at an even 100, so I'm not going to screenshot this because it's a nice X equals 100. And again, I'm just using that equal sign as a revolving door because I like to have what I'm solving for on the left-hand side. But that's just me personally. Right? So I would need exactly 100 spoonfuls of peanut butter. We would need 100 spoons of peanut butter, scoops or whatever it was. Nice. So, right, even if it doesn't feel like it, I encourage you to go back to that question maybe later and just kind of convince yourself that you would have been able to find it, right? But now you have kind of the mathematical language to go with it. So how we're going to use this section is mostly in calculating taxes, right? So you have gone out for dinner and now you have to tip, and you want to tip a certain percentage, right? And that kind of thing. And so I'm going to grab example 52. And it is from here, but quite a bit down. So lots more examples. But I'll tell you on the quiz, the question is going to be like what we're solving in the next 2 examples. Where is it? In one example, 52. Okay. So it says, last time I ate out, my bill was $45 before 7% tax and a 15% tip. I guess things have changed on the bill after tax. Okay, so the calculation goes, so you get your bill and it was $45. and then plus tax, right? And then that's the total amount that you see on your bill. And then you have to tip 15% on that, right? And so we want to find out how much did my night out cost me? And so how am I going to do this? Okay, so my meal itself was $45. Okay, and so the total, or sorry, the cost, how am I going to do this? Oh yeah, I'm going to do it in 2 phases, right? Because that's how the bill is calculated, right? So I order my meal, and then the bill comes and it has taxes on it. So let's just solve for the bill amount, right? And then we can add the tip amount. Okay, so I am going to break it up into 2 phases. You can get fancy with it and do it in one. But here, so the bill amount, right? And this is before the tip, but after tax, is going to be $45 plus tax. Yeah. Okay. How do I find that that tax? The tax is 7% tax, which is 7% is 0.07, right? Which is 7 divided by 100, right? So is 0.07 of $45. Notice how I took that percentage and I divided by 100 to get that proportion, and that's the one that I'm going to deal with. I am still finding 7% of $45, right? But when I just take 0.07, I can just multiply it by 45. Okay. And so here, right, I have the bill amount, which I'm trying to solve for, is $45 plus, and then 7% of 45. So how I'm going to write that is I'm going to write $45 times 0.07, right? This becomes 7% of $45. Right, that's how I calculate that. 45 times 0.07. So that's where we need to use the proportions. All right. Okay. So now this is probably not how you solve for things in the store, right? So usually if you're out shopping and you want to figure out the total price of something, then what do? You multiply the price on the tag by 1 point. I guess it's 1.2, right? In BC, I don't know, 7%. That was a while ago, right? Or maybe it's on food. Can never keep track. Anyways, so what are you really doing? You're doing 45 times 1 plus 45 times 0.07, right? And so here we can factor out, right, this common factor of $45. And so we get the bill amount, right, is going to be the total cost, but then you have to tip on there, is $45 times 1 plus 0.07, right? 1 times $45 plus 45 times 0.07, right? So then here, 1.07. So the bill amount is going to be $45 times 1.07. Right. This is probably where you would have jumped to immediately, right? I just wanted to show you where that comes from. Okay. This is how we often calculate prices after tax. right? Depending on what the tax is. It's 12%, 1.12. It's 7%, 1.07, right? But it's important that you have that 1 in front. Right? What does that help us do, right? Then you don't have to add it to 45, right? You can just find the total. So here, 45 times 1.07 is, let's go here. 45 times 1.07 is 48.15. Nice and even, already rounded. So the bill amount is $48.15 even. Nice. Okay, so that's what the cash register has already done. And then now the bill is being walked over to you. And now you have to calculate your taxes here, right? Or sorry, not your taxes. You have to calculate your tip. And we've decided we're going to do a 15% tip, which used to be amazing. Now it's not, I guess, not that good, but anyways, things change. So then the total cost is the bill amount plus the tip, which we said was going to be a 15% tip. This is the same situation, right? Except now the bill amount is what we're tipping on, right? And so we have the total costs is the bill, which is $48.15 plus the tip, which is 0.15 of $48.15. And so 48.15 times 0.15, right? Which I can rewrite. So you could just solve this if you wanted to. That's totally fine. Or I prefer to pull out that common 48.15 times 1.15. Keep messing up here. 1.15. Nice. Which puts me at, so I'm going to use that previous answer. So there's that A and S button that I'm going to use. So that previous answer times 1.15. I get $55.37.25. But because it's money, I have to round to 2 decimal places properly, right? 7 is followed by 2, so it just stays at 7. So 55.37. Nice. Okay. So that one got us all warmed up. How about a little bit trickier is working in reverse? Okay, so that example is going to be 53. Example 53, I'll put it here. A local pub has offered a $10 dinner, which includes, right? So now it includes 9% tax and a 15% tip after tax. Okay, so that $10 is what you're paying, the final amount that you're paying. And so now we want to know what's the cost of the dinner to the pub, right? So really they're taking in $10. They're saying, all right, yeah, great deal. You're going to come in here, give us $10 and it's all taken care of. Okay. But really there is a secret price, right, of the meal itself. And that's what we want to find. Okay. And so what we're doing, right, is we're working in reverse back to this cost, right, essentially. Okay. I'm going to show you two different ways of doing it, right? And just pick whichever one makes more sense to you. They do the same thing. It doesn't really matter as long as you arrive at the same answer. Okay. So we've got, I'm going to use kind of similar notation here. So the total cost is, and let's see here, let's do the bill amount, right, is the bill plus the tip. Okay, so just using the same kind of notation, but now we know different information, right? And so I've got the total cost is $10. And the bill and the tip, right, is going to be 15%, right? The tip is 15% of the bill. And so here, what I'm going to rewrite is the bill plus the tip times 0.05, or sorry, not the tip, but the bill times 0.15. Right? Because I can't have two unknowns. I only have one equation so far, right? And so I'm going to need to rewrite the tip in terms of the bill, which I can do, right? It's the bill times 0.15. And so now I can extract the bill, right? Just a placeholder for some amount times 1.15, right? And 10 is the bill times 1.15. Solving for the bill, then, what do I have to do? I have to divide both sides by 1.15. Okay. So then the bill, and in the same move, right, as divided by 1.15, I'm also going to put the bill on the left-hand side and 10 on the right-hand side, right? I'm just making that switcheroo. So the bill is 10 divided by 1.15. Okay. If it's been a while since you did math, right, then this is kind of a quick move here, right? But 10, you're still dividing both sides by 1.15, and then I'm just doing a switcheroo. Okay. You can keep them on the other side if you want, but like I said, I like to have what I'm solving for on the left as soon as I can. Okay, so then the bill amount is going to be 10 divided by 1.15. So let's do that. 10 divided by 1.15 is $8.6956, which is going to round up to 70, right? And so here, 86956. Just trying to. $8.6956. 52174. To two decimal places, right? And just as a refresher, the 9 is followed by a 5, which means I need to round up, but then that goes into the 6, right? And so now I have $8.70. So the bill amount is $8.70, right? But the bill amount includes tax. Okay. So, and I want to use the same. Oh yeah. Okay. Now I'm going to do the same thing, right? I'm going to tease out that I think it's 9% tax from the bill, right? So just how I pulled out 15% tip from the total, right? I'm going to pull out 9% tax from the bill. Okay. So the bill is the dinner cost plus tax. Notice that this bill here, this bill is what I'm going to be using here, $870. Okay. And I want to solve for the dinner cost, right? The meal itself. Okay. Tax, I'm going to rewrite as the dinner cost times 0.09, right? 9% of the dinner. So the bill is going to be the dinner cost plus the dinner cost times 0.09, right? 9% of the dinner cost. So now I can pull out that common dinner cost, and I have the bill is the dinner cost times 1.09. Right. But once you start to see that pattern, you don't have to write out all these steps, right? So once you recognize that, okay, I'm basically doing the same thing I just did, right? But now the dinner cost is what I'm solving for, and the taxes is 9% of the dinner cost. So you can just jump straight here if you're comfortable, right? But where it came from is through this. Okay. So then the bill amount, now I'm ready to put it in here. Right, 870 is the dinner cost, which is what I want to solve for, times 1.09. Dividing both sides by 1.09, I can solve for the dinner cost is 870 divided by 1.09. So 870 divided by 1.09 puts me at 798. Okay, and I'm just going to do that rounding here. So the dinner cost is 798, I guess. 165 1376 165 1376. $798, right? That would be the price on the menu, $798. What the price on the menu would be. You could speed up this calculation if you wanted to, right? How? We said the total cost is the dinner cost plus tax, right? First, which is the dinner cost times 9%. Just forgetting the percentage here. Right. So, or this is just another way that you could solve it if you wanted to, right? And there are many, many other ways. I just want to show you a couple, right? So you've got the dinner cost plus taxes plus the tip. So now what you have is the total cost is 10. And the dinner cost plus the dinner cost times 0.09 plus the tip, which is what? The dinner cost times 0.09 times 0.15, right? If you think about, okay, so it was the, lost myself. Okay, this isn't how I had it in my notes. So you know what I'm gonna do? Just gonna backtrack here. Also because I'm running out of room, but that shouldn't matter, but it does. So the taxes, how do I add on the taxes to the dinner cost? Right, we already learned that 1 plus 0.09 trick, so let's just use that. So the dinner cost times 1.09, right? This step adds the taxes, right? So that's the total dinner cost plus the taxes, right? But then if I multiply by 1.15, it also adds the tip. So then if I solve for the dinner cost, right, now because I'm multiplying both of these here, then I need to divide that over to the 10, right? So 10 divided by 1.09 times 1.15. And so I have the dinner cost is 10 divided by 1.09 times 1.15. You can keep the 1.09 in brackets. I just think it's a little bit cleaner if we don't. So now what I'm going to do is I'm going to calculate that. And I'm going to have 10 divided by 1.09 times, making sure it stays in the denominator, right, times 1.15. And I get a slightly different answer. Why? Because I used a rounded value up here. So let me just, so loud. That's so I can hear you, but I'll just bring this here. Right. And so these two slightly different answers why? Since we used 8.70, oh, shouldn't have cropped it so tight. Okay, since we used 8.70 instead of 8.6956527174, and then it clearly continues further, right? And so these are slightly different answers since we used 8.7 instead of 10 divided by 1.15 previously. So you can see the difference. I mean, in terms of our final result here, once I round 7.9776, it's gonna be 7.98, right? Which is exactly the same answer that we got once we rounded, right? But after rounding, we arrive at the same answer. But after rounding, the final amount to 2 decimal places. Can't remember if I've mentioned it before, but I use DP quite often, decimal places, right? And so that's good to have up your sleeve. So, but after rounding the final amount to 2 decimal places, we arrive at the same value, right? Which is 7.98, which is that cost of the meal. Okay, nice. Just have a look here. Okay. So this is where quiz number 1 goes to. Okay. Just so we don't slip too far behind, I am going to start section 2.1, but 2.1 is not on quiz 1, right? It'll be on quiz 2. So I'm going to start it here. So I can't remember what chapter 2 is called. So I'll add that in later. Maybe maybe it'll stay here. Introduction to Microeconomics. How fancy. Introduction to Microeconomics. Yeah. 2.1, we're going to start with linear functions and graphing. We've already seen linear functions. Linear functions are what? They're just straight lines, right? And so y equals mx plus b is the typical setup for a straight line, right? And so the equation of a straight line is something like y equals mx plus b typically. Okay. I don't know why. I'm sure there's a reason why we use m instead of a or something like that, but m is the slope, right? In general, whatever is attached to the x is the slope. Okay. So m is the slope. Okay. Whatever value is attached to the x is the slope. Okay. So here, right, we've got that x and whatever value is attached to the x is a slope. So that'll help you, right? You could write a plus bx, right? So then, and I'll write that down once we're done talking about b here. But so it doesn't matter what the variable names are, right? It's what they're attached to. The values on their own, right? B is the intercept. In fact, it's the y-intercept, which we rarely talk about the x-intercept. So often we'll just say intercept, but it's the y-intercept. So B is the y-intercept. And it'll be whatever value is on its own, right? Not attached to an x. Whatever value is on its own. The y-intercept, just as a kind of graphically, the y-intercept is where a line crosses the y-axis. So where the line crosses the y-axis. Right. Which is really what? It's where x equals 0. So if we look at just a typical graph here, right? You've got your x-axis, you've got your y-axis, right? And so here at x equals 0, right? You're going to have some value of y where this line crosses the y-intercept. And so, for example, in my, I should draw one that goes through the point there, maybe like that. All right. So here, how we denote a point on a graph is x comma y in round brackets, right? That's the coordinate of that point. And so here I've got 0 comma y, right, is the y-intercept. So it's important to remember that when x is 0, that's the y-intercept, right? Whatever the value of y is where it crosses the y-axis. Right? Similarly, you can talk about the x-intercept, right? Where y is 0, right? If you go down this y-axis, then here, what's here? Here at the origin, 0, 0, right? That's called the origin. Mm-hmm. 0, 0. Mm-hmm. X is 0, y is 0. Mm-hmm. So we're going to focus on the y-intercept, but it's good to know what it looks like, right? Because one of the things that we have to do in this course is we have to draw straight lines, right? It's one of those skills that you're expected to have, and this is the course where it was decided that we cover it. And so, I don't know, it's just kind of fun and something to work on. Okay, so instead of y equals mx plus b, we can write this many other ways. Oh, sorry, I see how it's lagging here. Okay. Let's see if it catches up. Okay. So we could write y equals mx plus b, or we could write y equals a plus bx. So notice here that b is not necessarily used to denote the y-intercept, right? It's just in that case, right? So here, or what color did I use? M is the slope, whereas here b is the slope. Here b is the intercept. It's understood it's the y-intercept. Here a is the intercept, y, because it's on its own, right? It's not attached to the x, right? So you want to be careful when you're reading these things, right? Whatever's attached to the x, that's your slope. Okay. So what's fun is whenever you have an equation with just an x and a y variable, right? So only two variables, then we can rewrite it as an equation of a line. Okay. So whenever we have an equation with only two variables, right? X and Y usually, right? It can be A and B or whatever, but P and Q is what we'll see later on, but just X and Y. Right, so whenever we have an equation with only two variables, we can rearrange it into the equation of a line. We can rearrange it to the form y equals mx plus b. How? by solving for y, right? Just getting y on its own, and then everything, if we've collected like terms and simplified, it'll become in this form, right? By solving for y. For y and simplifying. Yeah. So we need to be able to graph straight lines, right? It seems easy enough, right? But I'll give you kind of the toolkit that we need. So how do we graph straight lines? Yeah. So if we have some linear equation, right, which is just an equation of a straight line. So given a linear equation, which is just y equals mx plus b, right? Such as y equals, let's do something breezy like 2x plus 1, right? The slope is 2 and the y-intercept is 1, right? You can probably go ahead and just graph this. That's totally fine. But in order to have a method that allows you to deal with something that with more difficult slopes than just 2, for example, and more difficult intercepts than just 1, right? I want to give you a couple of tools that'll always work. Okay? And so what we're going to do is we're going to find 2 points on a line, because if you have 2 points, right, it doesn't matter where they are, you can always use a straight edge to connect to the 2 and then extend the line, right? So you only need 2 points on a line in order to draw that line, right? And so that's what we're going to do. Okay. And so in order to draw a line, we need to find 2 points on the line. Then we can use a straight edge. So usually if we're in class, then, you know, I encourage you to use kind of, you know, a piece of paper or something, and you just draw along that. It doesn't have to be a ruler. It can be anything. Often I'll use the edge of my calculator, right? It's just to have the skills of drawing straight lines. It's not actually, you know, we're not actually going to use them for much beyond that. Okay, but so we need to find 2 points on the line. Okay, then we draw those on our grid. Then draw those points on the grid and connect the 2 with a straight edge and then extend the line. And connect the 2 lines with a straight edge. And extend the line. Yeah. So how I'm going to do it is I like to make a table of values. Okay, and of course you only need 2 points, right? Anywhere you can connect them and they make a line, right? And so but it's helpful to have 3 points just so you can double check and make sure that they are all on the same line. But I'm just going to do 2 because I'm lazy. Okay, so here in terms of our steps, step 1 is I'm going to make a table of at least 2 values of x. Of at least 2 values of x. then use the equation. Use the equation to find the corresponding values of y. Then plot the XY coordinates. Plot the XY coordinates. These are called ordered pairs. Just in case I call them that. Usually I don't, but just in case it comes up on a graph. And then connect the points and extend the line. So if we want to draw something like y equals, and I see it's kind of lagging here, y equals 2x plus 1, what am I first going to do? So step number 1 is make a table of at least 2 values of x. Now, I like to pick convenient values of x. Now that depends on what the equation is, but usually x equals 0 is a nice way to start the day, right? And so here I'm going to make a table of values of x. So 2 values of x. I'm going to start with x equals 0. And remember, y is 2x plus 1. So here, right, when I use x equals 0, I can solve for y, right? And so I have y equals 2 times 0 plus 1. So y must be 1, right? That's also from the equation. I can see that this is the y-intercept, and by definition, the y-intercept is when x is 0, right? But that's what makes it a convenient value of x, okay? And so in terms of my x, y coordinates, right, or their ordered pairs, right, I'm going to be here at 0, 1. That's point number 1 that I'm going to draw. Now I am going to move this over just a smidge here. And I'm going to make a note here to pick convenient values of x. Right. Easy to solve for y is what I mean, right? You could put in x equals 1/3, but then it makes it really hard to kind of solve, right? And so what's another easy value of x that I could put in here? How about x equals 2, right? I don't want to have it too close, right? You could use x equals 1, right? When x is 1, y is 3, right? 2 times 1 plus 1. Okay. And so, but I'm going to move it out a little bit just so I have a little bit more room. So for example, I'm going to use x equals 2. And so y is 2 times 2 plus 1, putting me at 2. When x is 2, y is 5. And so now, right, we know that these 2 points are on the graph. And so I can draw those on the graph. And maybe, just maybe, because I don't want to use another page here. What if I do this? Because I'm just sketching this myself. I'm not doing anything fancy here, right? But what I'm going to do is I'm going to take these ordered pairs, right? When x is 0, y is 1. Let's put that here. 0, 1. Right, so here are 0, 1, 2, 3, 4. This is not going to look good because I'm just making up these axes, but that's because I want to end in 2 minutes here, so you have time to think about the quiz. So here, 1, although you have until tomorrow, right, at 1:30 tomorrow to do it, so don't rush into things. 3, 4, 5. Okay, so I had 0, 1, I've drawn that one was easy. How about 2, 5? What am I going to do? I'm going to put it here. X equals 2 and y equals 5. So 2, 5 goes there. And then my final step is to connect these two. Oh. And they extend. But let's see if I can. There. Ta-da! Right, so that's how you're going to draw a line. Nice. Okay. I think that's good for today. And we are ending early because I feel like I owe you time to do the quiz. The quiz would obviously be in class if we were in person. And so now this is my equivalent, I guess, where I let you go early. But if you have any questions, let me know, but I will end this recording. And